Okay, let's unpack this. We've all seen the claims surrounding the humble blueberry. It's the marketing gold standard for superfoods, frequently touted as the king of antioxidants.
Oh, absolutely.
It's in every health article, every gym smoothie recipe. It's, everywhere.
And historically, when a food achieves that kind of universally praised superfood status, our job immediately becomes one of, well, extreme skepticism.
Right.
Most superfood narratives turn out to be about 10% fact and 90% aspirational marketing fluff once you apply rigorous clinical standards.
Absolutely. So today, our deep dive mission is to strip away all of that marketing hype and find the true, clinically validated signal in the noise. We have compiled a massive stack of high-quality sources for you: clinical trials, systematic reviews, and meta-analyses, all focused on the Vaccinium species.
The tiny, powerful blueberry.
Exactly. Our goal is to extract the true, clinical, evidence-based understanding.
And we are focusing exclusively on the established, trustworthy human science. That means we're prioritizing human randomized controlled trials, or RCTs, and systematic reviews. Specifically, we're looking for evidence that the scientific community rates as moderate or high confidence using the grade quality assessment system.
So no weak observational studies.
None. We're here to define the most effective uses, the precise therapeutic doses, and, most importantly, the specific populations that genuinely benefit. This isn't vague wellness, this is precision health.
Let's start then with a fundamental question. What are we actually consuming? If the blueberry is the high-performance delivery vehicle, we need to know what precious cargo it's carrying and how much of it actually gets to its final destination.
So when we talk about the bioactive engine, the primary ingredients are polyphenolic compounds. And the most famous class, the ones responsible for that distinctive deep blue and purple color, are the anthocyanins.
And the research doesn't just mention anthocyanins as this one, monolithic thing. I was surprised to see how many specific compounds are named as key players in the successful trials. It's not just one magic bullet.
That chemical diversity is actually key to understanding the subsequent effects. The primary 5 anthocyanins we see consistently cited are, malvidin-3-galactoside, delphinidin-3-galactoside, cyanidin-3-galactoside, petunidin-3-galactoside, and peonidin-3-galactoside.
Very mouthful.
It is. And the important part for you to know is that the specific ratio and total concentration of these compounds can vary wildly. I mean, we see a range reported from 25 to almost 500 milligrams of total anthocyanins per 100 grams of fresh weight.
Wow, a 20-fold difference.
A huge difference. And it depends heavily on the cultivar, the growing conditions, ripeness, everything.
That near 20-fold difference confirms that sourcing and variety selection really matters if you're trying to hit a clinical dose. It shows why just eating a handful might not cut it.
It's why the science uses standardized powders. And while those anthocyanins are the headline stars, we have to remember the supporting cast, which contributes significantly to the synergy.
Right, it's never just one thing.
Exactly. These include other important polyphenols like chlorogenic acid, quercetin, resveratrol, and pterostilbene. The overall health impact we observe is almost certainly the result of all these molecules working in concert, not just the single star.
Okay, now let's get into the finding that truly flips the conventional wisdom on its head, because here's where it gets really interesting. The bioavailability paradox. We've been told these compounds are magical, yet the science shows they barely get absorbed as they are.
This is the fundamental reason why researchers initially struggled to link consumption to sustained benefit. If you consume the intact parent anthocyanins, the absolute bioavailability, so the amount that gets absorbed into your bloodstream as the original compound, is incredibly low.
How low are we talking?
We're talking less than 1%.
Wait, less than 1%? If that's true, how in the world are we seeing these robust 6-month high-grade clinical effects on blood vessels later on? It's the only active ingredient.
It's because the magic doesn't happen in the stomach or the small intestine. It happens much further down thanks to our internal partners.
The gut microbiome.
The gut microbiome. While those tiny concentrations of intact anthocyanins do peak quickly in plasma within about 1 to 2 hours post-consumption, that window is fleeting. It's a tiny, brief signal.
So that's the acute effect people might feel.
Perhaps, but the real sustained benefit comes much later, driven by the extensive gut microbiota metabolism that happens deep in the colon.
So the microbiome is essentially the body's internal, highly specialized chemical refinement plant.
That's a perfect analogy. Think of the parent anthocyanins as the complex, raw ore. They're too large and cumbersome for the body to absorb and utilize immediately. Your gut bacteria are the sophisticated chemical processing system that breaks them down.
Into what? What are they becoming?
They're broken down into smaller, more functional, highly bioavailable compounds called phenolic acids. These microbial catabolites are what truly drive the long-term structural benefits we observe.
And those catabolites, the refined nuggets, are what we see sticking around for hours. The sources highlight key microbial byproducts like protocatechoic acid, vanillic acid, and hippuric acid.
Precisely. Unlike the parent compounds, which vanish quickly, these metabolites can linger. One really important pharmacokinetic study showed that protocatechoic acid metabolites could still be detected in the plasma up to 24 hours post-consumption.
24 hours.
24 hours. This persistence is absolutely essential, and it proves why daily consistency matters much more than simply chasing an acute spike. It's the constant supply of these downstream metabolites that keep the body's systems optimized over time.
That explains why trying blueberries for a day won't achieve anything. You're not building up that reservoir of active compounds. It's a fundamental restructuring of your vascular health over months, fueled by these persistent metabolites.
It is. Now, let's translate this into actionable advice for you listening. Form and potency. How do you maximize the delivery of this precious cargo?
The processing method is paramount. What specific forms enhance bioavailability?
The strongest enhancer we see in the trials is freeze-drying. It sounds simple, but it's incredibly effective.
Why freeze-drying specifically?
Freeze-drying maintains 90 to 95% of the original anthocyanin content compared to fresh berries. And what's more, some clinical studies actually show that freeze-dried powder leads to higher plasma concentrations of these bioactives compared to consuming the fresh, whole berries.
That's a key insight, especially for people who need to use concentrates or powders to reliably hit the necessary high doses we'll discuss later. It's not a compromise. It might even be an upgrade.
It might be. And we also have a fascinating, highly specialized finding about formulation stabilization. One randomized controlled trial demonstrated cognitive benefits at an incredibly low dose, just 7 milligrams of anthocyanins daily.
7 milligrams. It's almost nothing.
It's tiny. But it was effective because the extract was stabilized with specific thiols like L-cysteine and L-glutathione. This suggests that protecting the fragile anthocyanin structure from degradation at physiological pH is a major lever for enhancing efficacy. Sometimes it's not about quantity, it's about protection.
That's the definition of precision health making. A tiny dose maximally effective through smart formulation. Now for the critical don'ts. What actively reduces the power of the blueberry?
The primary enemy is heat. Our sources are unambiguous on this. Heat processing causes significant degradation.
How bad is it?
You can lose between 20 and 50% of the anthocyanins just by cooking them at 90 degrees Celsius for half an hour. Boiling them for just 15 minutes can destroy 50% of the content.
So if I bake them into a muffin, I'm essentially destroying the active ingredient I'm trying to consume. It becomes a treat, not a therapeutic food.
Precisely. It tastes good, but the medicinal value is largely gone. The second major factor is co-consumption with high-sugar processed foods.
Why is that?
It causes a rapid insulin spike. This spike may counteract the immediate vascular benefits the polyphenols are trying to deliver. If you're using blueberries for cardiovascular maintenance, ditch the sugary processed pairings. A smoothie with added sugar is working against itself.
And finally, the infamous dairy question. Does my morning yogurt or smoothie ruin the benefits? The internet is so divided on this.
And for good reason. The sources provide conflicting data, which is why this topic remains murky. Some research suggests dairy proteins, particularly milk, may bind to polyphenols, reducing plasma antioxidant capacity and absorption. One small study showed a 30% reduction in plasma antioxidant capacity when berries were consumed with milk.
Okay, so that's the case against dairy. But other research suggests the protein might stabilize the compounds for the journey to the colon, where they are finally processed by the gut. That's a huge conflict.
It is. The opposing view, often seen in preclinical models using complexation with alpha-casein, suggests that protein protection might actually enhance the concentration of those beneficial metabolites later in the gut.
So what's a practical advice for someone listening right now?
Practically speaking, since the evidence is conflicting, the most helpful advice for you is the no dairy trial. Try consuming your therapeutic dose of blueberries away from heavy dairy for a week or two. Pay attention. See if you notice a difference in cognitive function or energy. It's the best way to tailor the science to your individual body.
A great way for you to customize the science. Okay, moving on to where the science is indisputably strong. If you want one reason, backed by the highest quality data, to eat blueberries, it's for your plumbing, your entire vascular system.
The evidence here is rated consistently high grade. Blueberries show the most consistent and high-quality evidence for improving cardiovascular function, specifically targeting the health of the endothelium, the crucial, delicate lining of your blood vessels. This is where long-term prevention begins.
And the gold standard measurement for endothelial health is flow-mediated dilation, or FMD. FMD is essentially a measure of how flexible and reactive your arteries are. Can you break that down for us?
Of course. So during an FMD test, a clinician will put a blood pressure cuff on your arm, inflate it for a few minutes to temporarily stop blood flow, and then release it. The sudden rush of blood or hyperemia should cause a healthy artery to dilate, to widen in response.
And FMD measures how much it widens.
Exactly. It's a direct, non-invasive measure of how well your endothelium is producing nitric oxide and responding to stress. A higher FMD percentage is a very good sign of vascular health.
So what did the meta-analyses find in terms of concrete, measurable improvements in FMD?
The data is highly consistent and impressive. A recent meta-analysis of 11 RCTs found that chronic blueberry consumption leads to a sustained improvement in endothelial function, measured by an FMD increase of plus 1.50%.
Okay, plus 1.50%. That sounds modest to a layperson, but in the context of preventing heart disease, that number is highly significant. Why is that small percentage change so clinically powerful?
It's highly predictive. This seemingly small improvement in FMD is clinically meaningful because, based on prospective epidemiological data tracking large populations, the specific magnitude of improvement predicts a substantial 12 to 15% reduction in long-term cardiovascular disease risk.
Wow. A 12 to 15% reduction in the risk of events like heart attack or stroke just from incorporating a cup of berries daily. That moves the blueberry out of the healthy snack category and into the realm of legitimate preventative medicine. That is a massive distinction.
It is, and this level of benefit was consistently demonstrated, particularly in trials lasting 6 months among patients who already had existing metabolic syndrome or were otherwise at risk. So it's especially powerful for those who need it most.
Beyond just the dilation of the blood vessels, blueberries also appear to tackle the stiffness of the arteries, which is a key marker of aging and cardiovascular risk.
Absolutely. Think of it like a hose. A new hose is flexible, an old one is stiff and cracks. Arteries are the same. Long-term RCTs, typically lasting 8 weeks to 6 months, observed significant improvements in arterial stiffness.
And how do they measure that?
With 2 different metrics. One is pulse wave velocity, which measures how fast a pressure wave travels down your arteries. Slower is better, and they saw a reduction of -6.5%. The other is the augmentation index, which saw a reduction of -2.24%.
So, in simple terms, the arteries are becoming more elastic, more youthful.
Exactly. This means your heart is pumping against less resistance, which improves overall circulatory efficiency and reduces strain on the heart muscle itself. This was particularly evident in at-risk populations, like postmenopausal women with pre- or stage 1 hypertension.
So how does this mechanism work? We know the gut-derived phenolic acid metabolites are the real players, but what are they doing inside the vascular wall to cause this sudden dilation and flexibility?
The core mechanism is improved nitric oxide bioavailability and a corresponding reduction in oxidative stress markers like 8-isoprostane. Nitric oxide, or NO, is the key signaling molecule that tells the smooth muscle cells in your blood vessels to relax and widen. That's vasodilation.
So more NO, better flow, more flexibility. Simple enough.
But here's the nuance that the clinical data highlighted. Blueberries don't necessarily increase the synthesis or production of nitric oxide. It's more clever than that. They seem to protect the NO that is already present from being oxidatively degraded by reactive oxygen species. They are protecting the supply.
A conservation mechanism, not a production mechanism. And how did researchers confirm that?
In a landmark 6-month metabolic syndrome trial, researchers found that daily blueberry consumption specifically enhanced NO signaling by increasing plasma levels of cyclic guanosine monophosphate, or CGMP.
Let's pause on CGMP because that is a highly technical term. For you listening, what exactly is CGMP in this context?
Think of nitric oxide as the starter pistol for vasodilation. When NO successfully hits the muscle cell walls, it triggers an enzyme, and CGMP is the secondary messenger. It's the internal confirmation receipt that the signal was received and the relaxation process is now happening.
Okay, so it's the proof that the message was delivered.
Precisely. By seeing a measured increase in CGMP, researchers confirmed that the NO signal was getting through and successfully causing the vessel to relax. This strongly suggests that the blueberry metabolites are acting as NO conservationists, reducing its oxidative destruction.
They act as guardians of the signal, ensuring the message to relax is actually delivered. That's a much more elegant mechanism than just a simple antioxidant boost.
Let's talk about the next major marker, blood pressure.
The evidence here is rated moderate confidence overall. Meta-analyses show moderate consistency for reducing BP, particularly diastolic BP, which is the bottom number. They saw reductions of -1.95 mmHg up to -2.2 mmHg in some reviews.
And the more important, top number systolic BP.
The overall pooled effect for SBP is often non-significant when you look across all populations, which is why it's easy to dismiss. However, if we zero in on specific high-risk cohorts, the signal becomes very strong. This is where precision targeting matters.
Give us the specifics of those strong signals. Who benefits the most? For example, in a high-quality RCT involving postmenopausal women with pre- or stage 1 hypertension, daily blueberry powder reduced SBP by a substantial -5.1% or -5.1 mNHg over just 8 weeks. That's a clinically significant drop.
And what about other groups?
Similarly, specific cohorts like chronic smokers also showed significant benefits, with a reduction of -3.92 mmHg SBP.
That's the crucial insight then.
Yeah.
The benefits are greatest in individuals whose bodies are already struggling to maintain vascular efficiency due to aging, lifestyle factors, or underlying conditions.
Absolutely. If you are a healthy young adult with normal BP, the needle might not move much. But if you have pre-hypertension, metabolic syndrome, or are a postmenopausal woman, the BP lowering effect is clinically robust and significant, contributing directly to that overall CVD risk reduction.
Now, what about the traditional lipid profile cholesterol? We always hear about that.
The evidence for lipids is mixed and generally rates as low confidence. Pooled effects and meta-analyses are very modest. LDL cholesterol, the bad cholesterol, decreased by a minimal manageable 0.07 millimol, and HDL cholesterol increased by plus 0.03 millimol.
So tiny changes.
Honestly, for a supplement, these numbers are barely outside the margin of error and likely not the reason you should be buying them.
So not a replacement for a statin, but perhaps a helpful complement.
Potentially, yes. We did find one detailed finding that points to a specific subtle benefit, particularly in statin non-users with metabolic syndrome. Daily blueberry consumption significantly increased both the HDL particle number, HDLP, and apolipoprotein, AI.
Why does the focus shift to particle number instead of the bulk cholesterol amount? That's a more advanced concept.
It is, because the effectiveness of HDL, the good cholesterol, isn't just about how much of it you have. It's often determined by the quantity of particles available to perform cholesterol efflux, which is the process of removing cholesterol from artery walls.
So more particles means a more effective cleanup crew.
Exactly. Increasing the particle number suggests a subtle but important shift toward a more robust anti-atherogenic profile, even if the total mass of LDL cholesterol isn't dramatically affected. It's an internal optimization, not a headline-grabbing drop in total cholesterol.
Understood. A powerful intervention for the vascular system. Let's shift gears now from the heart to the head.
The evidence for cognitive benefits is strong enough to earn a moderate grade rating, but it's crucial to understand that the benefits are highly domain-specific and target specific populations. This is not a universal smart drug.
And who are these target populations for cognitive improvement?
The strongest and most consistent evidence is found in older adults, particularly those aged 60 and above, and especially those already presenting with mild cognitive impairment, MCI, or subjective cognitive decline, SCD. This confirms the pattern we saw with the vascular data. The greatest benefits are seen when function is already declining.
What exactly gets better? Is it just a general feeling of alertness or focus?
Not at all. The gains are highly specific. We see significant improvement in particular types of memory, notably delayed memory, which is a form of episodic memory, and word list recall.
Can you give an example of what that looks like in real life?
Sure. Delayed memory is your ability to recall information after a period of distraction. For instance, remembering a grocery list you looked at 20 minutes ago, or recalling the names of new people you met at a party an hour later. The Krikorian 2010 trial, which used blueberry juice in older adults with MCI, demonstrated notable gains in this ability.
That's foundational memory retrieval, the kind of memory that lets you learn new names or retain new facts. What about speed? As we get older, processing seems to slow down.
Crucially, long-term RCTs, such as one lasting 6 months using wild blueberry powder in adults with mild cognitive decline, demonstrated a significant improvement in the speed of information processing.
How significant?
So robust that it effectively restored the participants' performance to the level of cognitively normal reference subjects of the same age.
Wait, restoring processing speed to a normal baseline just through diet intervention. That is a very powerful finding, suggesting blueberries can help reverse a key functional marker of cognitive aging.
It speaks to the potential for dietary intervention to optimize the physical system underlying cognition. It's not magic. It's better hardware support.
But you mentioned specificity, and we need to manage expectations for the listener. What cognitive domains did the research find did not improve?
This is essential to emphasize. Multiple high-quality RCTs found no significant benefits for working memory.
And working memory is what exactly?
That's your brain's mental scratch pad. It's the tasks that require you to hold and manipulate information actively, like doing math in your head or remembering a phone number while you search for a pen. The complex two-back task is a classic test for this, and blueberries showed no effect. They also didn't show benefits in broader executive function measures.
So blueberries are not a general cognitive enhancement pill. Their effects appear concentrated on optimizing memory consolidation and the sheer speed at which the brain can operate, not enhancing your short-term mental scratch pad.
Exactly. Don't take them hoping to be better at multitasking in the next hour. Take them to support your brain's structural health for the next decade.
Let's look at the brain mechanisms that support these gains. We've established the vascular connection in the body. Does that extend to the brain?
Yes, and it provides a crucial dual pathway for benefit. The first pathway is clearly vascular. Human fMRI and transcranial Doppler studies show increased cerebral blood flow and enhanced neural activation, specifically in task-relevant areas like the parietal and occipital lobes, which supports faster cognitive processing.
So the improved plumbing we saw in the heart extends directly to the brain, ensuring better fuel and oxygen delivery to the regions that are working hard.
That's right. Better blood flow, better brain function. The second pathway is neuroprotection.
So protecting the brain cells themselves.
Yes. We know those refined anthocyanin metabolites can cross the blood-brain barrier. Once there, they are observed to perform two critical roles. First, they reduce neuroinflammation markers, which calms down the brain's immune environment. Second, they help maintain levels of brain-derived neurotrophic factor, or BDNF.
And BDNF, as we've discussed before, is like fertilizer for your neurons. It's essential for neuronal survival, growth, and creating new connections.
Exactly. So they protect the neural hardware and improve the plumbing supplying that hardware. It's a comprehensive support system for an aging or stressed brain.
Moving beyond function to feeling. Mood and mental health. This area seems much more complex, rating low mixed grade.
It is the most complicated area, presenting a perfect storm of context dependency. On the acute side, a single dose of wild blueberry product has been shown to improve positive affect and executive function acutely within 2 hours in healthy young adults.
So a short-term mood lift.
A transient mood uplift or boost in energy for a short period, yes.
That sounds promising. But then we hit the 6-week chronic use trial involving people with moderate to severe depressive symptoms. And this is the paradox we absolutely need to address.
This is the finding that needs maximum clarity. In that 6-week RCT, chronic daily supplementation in young adults with clinically significant depressive symptoms actually resulted in worse outcomes than the placebo group.
Worse? How so?
The reduction in depressive symptoms was significantly greater in those taking the inert placebo. The blueberry group did not improve as much.
Wait, that is completely counterintuitive. Why would a food that gives an acute mood boost become detrimental when taken chronically in a vulnerable population? That makes no sense.
Researchers speculate this might be due to a potential hormetic response. This is the idea of an inverted U-shaped dose response. Hormesis means that while low doses stimulate a beneficial effect, chronically high doses may stress or overwhelm the body's existing compensatory mechanisms.
So that's a too much of a good thing problem.
It could be, particularly in individuals who are already experiencing high psychological distress and whose systems are already dysregulated. It's a massive note of clinical realism. Never assume chronic use is automatically better, especially when dealing with clinical conditions.
A necessary caution. We cannot extrapolate an acute mood boost into a chronic mental health treatment. But there was a positive finding in another young population, right?
Yes, the complexity deepens. One RCT in healthy adolescents, aged 12 to 17 years, reported significantly fewer depressive symptoms after only 4 weeks of wild blueberry beverage consumption compared to placebo.
So it helped in healthy teens, but not in young adults with depression.
Correct. This suggests that the effect may depend highly on the baseline mental health status and the age of the individual. The lesson for you is context is everything.
So we've covered the what, the why, and the who. Now let's get down to the brass tacks. What do I actually need to buy, and how much do I need to commit to?
Okay, we need to start with the effective dose and duration. And the listener must understand that consistency and volume are non-negotiable for success.
This isn't a sprinkle on your cereal situation.
Not if you want clinical results. For cardiovascular and vascular support, which has the strongest evidence, you must aim for 150 to 300 grams of fresh blueberries daily.
What does that look like?
That's approximately 1 generous cup. Or if you're using powder, the equivalent is 22 to 26 grams of freeze-dried powder.
It is absolutely crucial to note that the common half-cup dose, about 75 grams fresh, was often found to be sub-threshold and ineffective in trials. If you are serious about seeing that 12–15% CVD risk reduction, you must hit the full cup threshold.
Yes, dosage matters. Underdosing is the same as not dosing at all. Now, if your goal is cognitive support in older adults with MCI, the required dose is often even higher.
How much higher?
Up to 230 to 500 grams fresh equivalent daily. This is usually delivered via a standardized concentrate or powder, reflecting the greater biological hurdle of crossing the blood-brain barrier and affecting brain tissue.
And this is a marathon, not a sprint. What is the necessary duration?
The benefits are chronic, and they accumulate. You need a minimum of 8 WITs for blood pressure benefits, 12 weeks or more for cognitive function improvements to become statistically significant, and at least 6 months for those sustained, high-quality vascular benefits, like the FMD improvements.
Now let's bring back the fascinating timing strategy, the biphasic absorption, to maximize those cognitive benefits. How does that work again?
Since the active metabolites peak at 2 distinct times, there's an early peak around 1 to 2 hours post-ingestion from early absorption, and then a second later peak around 6 hours post-ingestion. Due to the microbial processing in the colon, researchers developed a biphasic strategy.
Tell us exactly how the listener can implement this.
It's simple. The strategy involves consuming half of your daily dose with breakfast and the second half with lunch.
I see. So you get 2 waves of active compounds hitting your system.
Exactly. This helps align both metabolite peaks with the typical peak cognitive demand window of the mid-morning and mid-afternoon. It's an intelligent way to ensure that improved cerebral blood flow and neuroprotective compounds are maximized exactly when your brain needs them most.
That is a phenomenal practical tip, turning simple consumption into a targeted strategy. Let's move to a necessary reality check: metabolic health and type 2 diabetes.
Overall, the evidence here is moderate and very specific. Meta-analyses show small but significant reductions in fasting glucose and HbA1c around miniature 0.32%.
That sounds good.
But, and this is a huge, boldly in people who already have diagnosed type 2 diabetes. The effects in the general non-diabetic population are much smaller or non-significant.
And what about insulin sensitivity? That's often cited as a major benefit, that they help your body use insulin better.
This is where we see mixed and often dissociated results. Some RCTs in obese insulin-resistant adults did show improved insulin sensitivity, with a common marker called OMA-IR decreasing by about 10%.
Okay, so there is some signal.
Yes, but other very high-quality long-term trials, including those using the gold standard clamp-assessed methods, which are much more accurate, found no effect whatsoever on insulin resistance.
Wait, that is a huge distinction. If the vascular function improved so much, with FMD going up 1.52%, but the insulin sensitivity didn't change in these high-quality trials, what does that imply for their mechanism of action?
It implies that the profound vascular benefits, the FMD improvements and BP reductions, are largely independent of improved glycemic control. Blueberries make your blood vessels better at doing their job, regardless of whether they make your insulin work better.
That's critical. Their primary role is circulatory maintenance, not a powerful intervention for blood sugar dysregulation.
Exactly. Don't rely on them to fix insulin resistance, rely on them to fix your arteries.
And for anyone hoping this is a weight loss secret,
the science is clear on this. High-quality trials, even those using very large doses like 50 grams of powder daily over 8 weeks, showed no significant effect on body weight, BMI, or overall body composition. The benefits are entirely internal and functional.
Finally, let's address cultivar. Wild versus high bush. Should you pay a premium for wild varieties?
Compositional analysis confirms that wild or low-bush blueberries, the smaller ones, generally contain higher anthocyanin content, sometimes up to twice as much, compared to the common cultivated high-bush varieties you usually see in clamshells at the store.
So they might provide greater benefit per gram.
They may, due to this density.
But if I use a standardized powder to hit my 25-gram dose, does it still matter?
Then the difference becomes minimal. Clinical trials show that when doses are standardized and matched for total anthocyanin content, which often happens when you're using concentrates or freeze-dried powders, both forms can be effective. Our conclusion: prioritizing the form, raw, frozen, or freeze-dried, and hitting the dose, 1 cup equivalent daily, is generally more important than stressing over the specific cultivar.
Excellent. We've established the dose, the form, and the duration. Let's close this deep dive by addressing the necessary questions of safety, potential interactions, and, perhaps most importantly, the massive gaps that still exist in the research.
First, the safety profile. This is pretty straightforward. Blueberries are generally recognized as safe, or GRAS, at food consumption levels, even at the high doses used in clinical trials.
What about adverse events in those long-term high-dose trials? Any side effects?
Adverse events are rare and mild. Even in trials using up to 600 grams fresh equivalent daily over 6 months, the only things reported were minor transient gastrointestinal symptoms, like bloating or loose stools, and that was only in less than 5% of participants. The high compliance rates in these studies speak to the excellent tolerability.
Let's tackle the medication interaction concerns, starting with the most common question: warfarin and blood thinners.
This is a widely shared theoretical concern due to the small amount of vitamin K in blueberries. It's about 9.1 micrograms per 100 grams fresh.
So is it a real risk?
Systematic reviews and current expert consensus suggest the risk is minimal. The amount is very low. Blueberries are generally considered safe for warfarin users. However, if you are initiating very large daily doses, say over 300 grams, regular INR monitoring with your doctor is always appropriate as a precaution.
And for those managing blood sugar with medication.
Since blueberries can improve insulin efficiency and show small glucose-lowering effects in people with type 2 diabetes, there is a potential for additive glucose-lowering effects with your medication.
So what should you do?
The recommendation is simple. Monitor your blood glucose closely when initiating large doses, but dose adjustment is rarely needed. Blueberries are not associated with hypoglycemia risk in human trials.
Any other significant interactions?
No clinically significant interactions have been consistently demonstrated in human trials, including with statins, where the vascular benefits appear complementary and beneficial alongside the medication. The safety profile is robust.
So what does this all mean? We have strong evidence for vascular health and specific cognitive benefits in older adults. But where does the science still fall critically short? What are the critical knowledge gaps?
There are 3 major gaps that future research absolutely must address, according to our sources. The first is the massive gap in longevity.
Meaning, does eating blueberries actually make you live longer?
We simply don't know, and our evidence here is rated very low grade. We have beautiful, compelling observational cohort studies that show people who eat more berries have a lower incidence of cardiovascular disease and type 2 diabetes, which strongly suggests lower mortality, but these are associations only.
Not cause and effect.
Exactly. We lack any direct human trials that measure lifespan, all-cause mortality, or true health span. Any current link is purely observational and speculative.
So we have very high confidence they improve the quality of your blood vessels today, but very low confidence they guarantee an extra decade tomorrow.
Yeah.
That's an important distinction for you to keep in mind.
Precisely. The second critical gap concerns the generalizability of the findings, and it's a major limitation: ethnicity.
Why does ethnicity create such a limitation for blueberries specifically?
Because of the heavy reliance on microbial metabolism, which we emphasize in Section 1, nearly all the high-quality human studies, over 95% of them, were conducted in predominantly Caucasian populations in the USA and the UK.
And we know that gut microbiome composition varies drastically across ethnicities and geographies.
Drastically. It's due to different diets, genetics, environments, everything. The efficiency of your chemical refinement plant, your gut microbiome, varies across populations. This means the amount of bioactive metabolites produced might be very different for someone from a different ancestral background.
So the results might not translate.
They might not. Until the research community addresses this gap, we cannot definitively claim efficacy across diverse global populations, meaning your personalized results may vary significantly.
And finally, the long view.
Most of the successful trials are short-term, lasting under 6 months. We have no robust, multi-year data on the long-term safety, sustained efficacy, or whether functional tolerance develops after years of high-dose consumption.
So we don't know if the benefits stick around after, say, 5 years.
We don't. Furthermore, we still need clearer human trials to definitively differentiate whether the benefits are driven by parent anthocyanins, early metabolites, or the late gut-derived microbial catabolites. Knowing which molecule does the heavy lifting is crucial for maximizing future formulations.
That makes sense. The more we understand which molecule does the heavy lifting, the better we can target the dose. Hashtag outro. So let's summarize this deep dive for you. Blueberries are not a miracle cure-all, but they are a scientifically supported, high to moderate grade tool for specific populations and specific goals.
That's the key.
If you are an older adult or have metabolic risks like prehypertension or metabolic syndrome, prioritize them for vascular health and cognitive support.
To see those meaningful benefits, you must adhere to the effective dose. Aim for 1 generous cup of fresh or frozen blueberries daily, or the equivalent 22 to 26 grams of freeze-dried powder.
And consume them raw or frozen to protect those heat-sensitive anthocyanins. Remember, duration is key. This is a commitment of months, not days. And you now know the nuanced areas. Avoid the heat, consider a biphasic timing strategy for cognition, and recognize that the benefits are focused on FMD, delayed memory, and processing speed, not working memory or general energy.
And that leads us back to the final provocative thought that builds directly on the bioavailability paradox. Since we established that microbial metabolism is the process that creates the most bioactive persistent compounds, those phenolic acid catabolites, the clinical efficacy of blueberries may depend entirely on the existing health and specific composition of your unique gut microbiome.
That raises a critical question for personalized nutrition, doesn't it? If my microbiome isn't set up to process these compounds, am I just wasting my money?
It's the central question, and it leads to this. Could optimizing your gut microbiome before starting blueberry supplementation, perhaps with targeted prebiotics or specific fiber, drastically increase the clinical benefits? Could that targeted intervention turn a modest health gain into a much more significant one by maximizing that crucial metabolite production?
So you'd be priming the engine before you add the fuel.
Exactly. That's a deep dive for another day.